Let us solve this problem. A ladder 10 feet long is leaning against the wall of a building. If the top of the ladder is sliding down the wall at the rate of 3 feet per second, how fast is the foot of the ladder moving away from the foot of the wall when the top of the ladder is 7 feet above the ground? Let us say this is the figure. This the blue part of the figure is the ladder. Let us represent the ladder by Z. So, Z is equal to 10 feet because according to the problem, the ladder is 10 feet long. And then the problem asked how fast is the foot of the ladder moving away from the foot of the wall when the top of the ladder is 7 feet above the ground. Let us represent this part of the wall by y. So y is equal to 7 feet. The ladder is sliding down the wall at the rate of 3 feet per second. So we are going to find the rate of change of y with respect to time, or the derivative of y with respect to t. And this is the dy over dt is equal to negative 3 feet per second. Negative because the ladder is sliding down the wall. This is the foot of the ladder, and this is the foot of the wall. As the ladder slides down the wall, the foot of the ladder moves away from the foot of the wall. Let us represent this by x. Let us assume the ladder is perpendicular to the ground. So this is the right angle and this is a right triangle. The next thing to do is to write the equation that relates the variables. The equation that relates the variables is the Pythagorean theorem. X squared plus y squared is equal to z squared. We are going to substitute 7 for y and 10 for z. So we have now x squared plus 7 squared is equal to 10 squared. This is now x squared plus 49 is equal to 100. We transpose 49 to the right side, change its sign from positive to negative. So we have now x squared is equal to 100 minus 49. This is now x squared is equal to 51. Extracting the square root of both sides, we get x is equal to square root of 51. This is the figure. Z, which represents the ladder, is equal to 10 feet. Y is equal to 7 feet. Dy over dt is equal to negative 3 feet per second. And the red part of the figure is x. We already solved for the value of x. We found out that x is equal to square root of 51. The next thing to do is to differentiate both sides of the equation that relates the variables. The equation that relates the variables, as we already said, is the Pythagorean theorem. X squared plus y squared is equal to z squared. Since the z is equal to 10 feet, we substituted 10 for z already in this equation. So we have x squared plus y squared is equal to 10 squared. And then depreciating both sides of the equation, we have 2x dx over dt plus 2y dy over dt is equal to 0. 0 because the derivative of a constant is equal to 0. 10 squared or 100 is constant. Next, we are going to substitute. We are going to substitute square root of 51 for x, and then 7 for y, negative 3 for dy over dt. So this is now 2 times square root of 51 dx over dt plus 2 times 7 times negative 3 is equal to 0. This is now equal to 2 times square root of 51 dx over dt minus 42 is equal to 0. We are going to transpose negative 42 to the right side of the equation. We change its sign from negative to positive, and then divide both sides of the equation by 2 square root of 51. So this is now equal to dx over dt is equal to 42 over 2 square root of 51. And using a calculator, this is equal to 2.94 to the nearest 2 decimal places feet per second. This is how fast the foot of the ladder is moving away from the foot of the wall when the top of the ladder is 7 feet above the ground.